So scalar multiplication is where we stopped yesterday. Now, I have used the word scalar a few times throughout the lessons because when we talked about doing elimination, solving systems of equations by eliminations, I talked about scalars. And scalar, what does that sound like? You're scaling something, making it bigger. And that's really what it is. When we scale something, we're either making it bigger or smaller. We're just increasing the size. In geometry, we will call that a dilation. We'll dilate something, make it bigger or smaller. So when we talk about this here, multiplying by a scalar, we're multiplying by a real number. We don't normally multiply by a variable, but it is possible. Because when working with matrices, a real number, often called a scalar, to multiply a matrix by a scalar, multiplying each element in the matrix by the scalar. This process is called scalar multiplication. Well, let's just actually look at it. Because that was a whole bunch of words, and there should have been a few more periods in there. So we want to perform the indicated operation. So here, we're wanting to scale this matrix by 2. So that means I'm going to multiply everything by. So I'm going to write it out. So really, we would have 2 times 3, and 2 times negative 2. Here we have 2 times, and 2 times, 2 times 2, and 2 times. Well, our first one, 2 times 3 would be, 2 times negative 2 would be negative 2, 10, 4, and
that's all it is?
That's it.
Does it get any more complicated than that?
I mean, we could multiply 3/4, but we could do decimals, we can do fractions, we could do any number, but the process doesn't change. We'd just be multiplying each element by that number. And you'll see with a lot of the stuff that we'll be doing, and we can have it be harder, and I put harder in quotations, in that we can use weirder numbers. So 3.714. We can use it as a scalar multiplication, but it's only harder in the sense that the numbers come out weirder and they're a little bit stranger to work with. The overall process of this isn't going to be any harder. It's just the numbers work out weird. Or there's more steps to get to the final answer because we're having to work with these weird numbers. Yes, it's not harder, it's just longer. Now the other thing is we can actually combine the scalars and addition and subtraction together. So when we do this here, we always want to apply the scalar first. Now, multiplication before addition or subtraction. Now when we multiply by the scalar, we can multiply with that sign going with it. And especially if it's going first, I'd take the sign with it. So for our scalar of negative 3, so we can say negative 3 times 5. Negative 3 times 0. Negative 3 times negative 2. And negative 3 times 4. Negative 3 times 5 is exactly, it would be negative 15. Negative 3 times 0 is 0. Negative 3 times negative 2 is positive 6. And negative 3 times 4 is negative 12. Question?
You have to do one side first, put that to its side, and then do the other side, then come back down and add it.
I was just doing this stepped out, because if you guys can see, especially with negative 3 times 5 is negative 15, negative 3 times 0 is 0. Go from this step to this step, that's fine. I'm just writing out so that we can see how it's all working. Because at this point here, then we would just add them together. Negative 15 plus negative 1. 0 plus 7. 6 plus 3. negative 12 plus 2. Well, negative 15 plus negative 1 would be negative 16. 0 plus 7 is 7. 3 plus 6, or 6 plus 3 is 9, and negative 12 plus 2 is negative 10. That's it. That's all we have to do for this here. Questions on this here? I think we just have those last two, don't we? Yeah, there's a boys and girls. Okay. So we have these two here, yes? So, are there any questions on this here? Do we feel pretty comfortable with this? Yes? I'm just going to make one up. Let's actually take that. Negative 7 ninths, 2, negative 7, negative 2, 3, 4, 5, negative 2, 7, negative 6. And let's subtract from it 8 15ths. 8, negative 7, 9, negative 41, 32, 67. Let's do 928. That sounds like a fun number. Negative 41 and 15. Yeah, let's do 3. 3 is a nice number also. Okay, neither one of those is an expo marker. So that's very exciting, yes? Because what? You don't want to solve that out by hand? Well, 8, negative 7. It'd take me a while.
If you're doing math in your head, do you ever lose your spot? Like, lose where you're at?
Yes.
Okay.
What was that, 968? 928. And 3. What did we learn about the 84s, these calculators the other day? They can do what? What can we put into these? Matrices, yes? So I could go, well, as long as I'm not writing on the board, because I can go second matrix and over to edit. Now both of these here are a 3 by 3. Let's see here, so 2, 3, negative 2. Negative 7, 4. That's supposed to be a 7. And then negative 2, 5, negative 6. Negative 6. So I went on and just put the first one in. And then I can go down to B and say we want another 3 by 3. 8. Negative 7. 9. Negative 41. 32. 67. 9, 2, 8. Negative 41. And 3. So I can put both of those in, yes? Now, plugging them in, I think y'all should be pretty comfortable with. We've done those a few times, yes? I mean, if not, we do have the videos to walk you kind of through that. Now, we want to multiply the first one we plugged in by what? Negative 7 ninths, yes? Well, I can go negative alpha y equals, enter, and it'll give me a fraction. And I can say 7 over 9. And then if I go second matrix and then hit enter next to A, I'm telling the calculator to take negative 7/9 and multiply by matrix A. And then what are we subtracting from it? 8 alpha y equals, enter, 15. And this is being multiplied by what? So I can go second matrix. Now I wouldn't hit enter because that would call up matrix A. I scroll down one and hit enter, and I have matrix B. Yes? Then I'll just go on and hit enter. I'm just going to think for a minute, and that's the answer. So really, these calculators will do addition, subtraction, scalars for us. And it'll do scalars and addition and subtraction, or any of these. Now, we haven't covered it yet, but multiplication is possible. If, for some reason, they do have these on the ACT, as they do, matrices do show up, and they're asking you to find the multiplication of A times B, or these two matrices, well, we can put them in as A and B. Then I can tell it second matrix A, second matrix B. I could put a multiplication between them or put them next to each other. It understands that it's multiplication. And hit enter. And it tells me what they multiply by. Now there's also something called inverses. Second matrix A. And I can take its inverse. I can put it to the -1. And hit enter. I don't like those decimals. I want fractions. See if we can go, yep. So those are the fractions for its inverse. So there's different functions we can do within it. And I think it might talk about determinants. I don't think so. Second math. Well, second matrix. Over to math. DET is the determinant. It'll tell us what the determinant is. I'm not messing with DIM. I have a feeling I know what it is. It tells us it's what? It's a 3 by? Yeah, it tells us the dimensions of it. I feel that's a little redundant because for us to put matrix A in, we had to put the dimensions in, so it's telling us it right back. I mean, if we're doing multiplication, that can be somewhat helpful because the dimensions do change when we multiply two matrices together. But we won't get into actually how to solve it by hand till a later date. But if it does pop up on the ACT before then, the graphing calculators will do it for us. Questions on this here? Do y'all feel comfortable with these? Then we will say that that is it.